welcome to the Geo Show. Before I dive into the topic of beaches, I just wanted to say a couple things. Thank you to everyone who has been watching and subscribing since I've been gone for over the last couple months. Now that summer is over, I'm ready to get back to my second job as an educational content creator. Along with new Geo Show videos coming out, my geologist friend, Tyler Cataclasis Robinson, and I will be hosting a podcast about the lighter side of geology. You can find the Schistcast wherever you get your podcasts, and our first episode will be on geology and video games, dropping in about 2 weeks. There is a trailer for it on Spotify and other podcast sites where you can go and subscribe right now. That way you'll be alerted as soon as the first episode drops. And now, on to our show. So the first thing we need to talk about when it comes to beaches is waves. Waves form when wind blows over water. The size of the waves depends on the wind speed, the area over which it is blowing, and time. The important parameters of a wave are its amplitude, which is the vertical distance between trough and crest, the wave length, which is the distance between crests and troughs, and speed. The water beneath a wave is disturbed to a depth of 1/2 the wavelength and is known as a wave base. Since the ocean is so deep, the wave bases don't interact with the ocean floor until it gets into much shallower water. A longshore current develops within the surf zone, the areas where waves are breaking, where waves approach the shore at an angle, and one part of the wave feels the bottom sooner than the rest. Swash and backwash on a beach move sediment along the shore. The combined effect of these two processes is sediment transport by longshore drift. Coasts that have experienced uplift within the past several million years tend to have irregular shapes and are dominated by erosional processes. Wave paths are bent where the coast is irregular and wave energy is focused on headlands. Rocky headlands are eroded into sea caves, arches, stacks, which are formed from wave-resistant rocks, and sea cliffs. And the areas around these features are eroded into wave-cut platforms. Over the long term, millions of years, irregular coasts are straightened. Coasts that have not been uplifted for tens of millions of years tend to be relatively straight and are dominated by depositional features, although deposition is also important on irregular coasts. Waves and longshore drift are important in controlling the formation of beaches, as well as spits, trombolos, bay mouth bars, and barrier islands. Beaches can be divided into zones, such as foreshore and backshore, and beach shapes typically change from season to season. Carbonate reefs and carbonate sediments form in tropical regions where there is little input of plastic sediments. The relative levels of land and sea have significant implications for coastal processes and landforms, and they have been constantly changing over geological time. Eustatic sea level changes are global in effect and are typically related to glacial ice formation or melting. Isostatic sea level changes are local effects caused by uplift or subsidence of continental crust, typically because of the gain or loss of glacial ice. Tectonic sea level changes are related to plate interactions. Net sea level rise leads to development of estuaries and fjords, while net sea level drop creates uplifted marine terraces and beaches. Humans have a strong urge to alter coasts for their own convenience by building seawalls, breakwaters, groins, and other barriers. Although these types of features may have economic and other benefits, they can have both geological and ecological implications that must be considered, like the loss of marine animal habitat. Please like and subscribe if you enjoyed this video. With that, I bid you adieu, and cheers. Also, shout out to my Patreon supporters, Tyler Cataclasis Robinson and a friendly doggo. Your continued support helps this channel immensely. Thank you.